पहले वो स्टार्ट करके आ जाओ. Assalamu alaikum everyone. Today we are going to start with AS level 9701 lecture video number 07, and in the last video 06 we were discussing hydrobromination of propene, which is an asymmetrical alkene, and we discussed that how an asymmetrical alkene results in two different structural isomers. And the focus of this video will be in explaining you that why one of the products is a minor product and the other one is a major product. That means they are formed in unequal quantities. One is more favored and the other one is less favored. So the explanation from 2002 till 2016 in your syllabus, if you will be solving past papers, old past papers, was given in terms of Markovnikov rule. And in 2016 onwards, another explanation was added, which is usually internationally more widely used explanation. It's called the stability of carbocation or the inductive effect. I'm going to explain each one one by one. First, we are going to discuss the Markovnikov explanation. Markovnikov was a Russian scientist who just basically, I think, observed that what's happening, and he just gave a statement, and he said that what he observes is that if you have an asymmetrical alkene and then there is a carbon with a double bond which has more hydrogens, like this carbon has more hydrogens, it has 2 hydrogens, right, and the other one has less hydrogens. So he said that the electrophile, which is hydrogen in this case, remember the electrophile is the one which carries the positive charge, the electrophile will be adding to the carbon, will be joining the carbon, will be bonding with the carbon which already has more hydrogens on it, like this one, this has more hydrogens. So the hydrogen should bond with this carbon, like in case number 2. So it should bond with this carbon which has 2 hydrogens rather than bonding with the carbon which has 1 hydrogen in case number 1. So that is why this product is major product, and because this should not happen according to Markovnikov, so this is less product, and that is why in some texts this is called Markovnikov product and this is called anti-Markovnikov product. So if the examiner asks that why 2-bromopropane is formed in larger quantities, your answer should be because the electrophile adds to the carbon with more hydrogens. If you think of it, it's not that much satisfying details. There was a scientist who just given a statement, and we don't know the background at what's happening. We are just believing his statement. Okay, this happens. Okay, so that's the major product. But there is more to it. So now I'm explaining the another view to the situation, and that is called stability of cation. This is a more scientific approach. If you think of it, that if this is less product, that is it's formed in less quantity, the minor product, that means that this carbocation was formed in less quantity. And if this is your major product, that means this carbocation was formed in less quantity. So we have to focus on that why this carbocation is formed in less amount and why this carbocation is formed in more amount. If we conclude that this carbocation was your minor carbocation and this was your major carbocation, that eventually led to your minor product and then your major product, then we have to think of it that the bond breaking anti-clockwise is less favored and the bond breaking clockwise is more favored. So we have to think of a reason that why formation of this carbocation is less favored and why formation of this carbocation is more favored. So that this topic is called stability of carbocations. I'm going to explain it over here. So there are like 3-4 types of carbocation. A carbon which carries a positive charge could be attached to 3 hydrogens. This is called methyl carbocation. Case number 1. Case number 2 is a carbon carrying a positive charge could be attached to only two hydrogens, and on one side it has a carbon side chain like this one. This carbon, it is attached to one hydrogen and two carbons. This is called a carbon side chain. This is called primary carbocation. Another case is a carbon carrying a positive charge could be attached to two of the alkyl groups. It is called secondary carbocation, and I am writing it over here. I think you might not be able to see that area. Lower 4 is that a carbon carrying a positive charge attached to only carbons on all the sides and no hydrogens. This is called tertiary. It's very easy to name them according to the number of either hydrogens or carbons attached around the carbon carrying the positive charge. If the carbon carrying the positive charge is surrounded by only 3 carbons, it's called tertiary. If 2 carbons, secondary. If only 1 carbon, then primary. Now what they say is that the tertiary carbocations are most stable and the methyl one is least stable. And as the number of alkyl groups keeps on increasing, the stability keeps on increasing. Why is that? Because anything with a positive charge is not stable. It's not a stable situation. Compounds which are neutral are stable. Substances which have charges are highly reactive. They are not considered to be stable species in chemistry. So this charge is actually a proton, and that carries 1.6 into 10 raised to power minus 19 coulombs positive charge because it's a proton. Here the charge is actually 1.6 into 10 raised to minus 19, but when it is attached to an alkyl group, the alkyl group has an inductive effect. What is an inductive effect? It's an electron donating group. That means it shares some of its electron charge density with the carbocation because it's positive, so the electrons move from this side to the carbon. And we can see that the charge over here is less than 1.6. I don't know the exact value. Let's assume it's 1.3 into 10 raised to power minus 19. Why this electrical charge has decreased? Because it's attached to an electron donating group, which gives its electron. Otherwise, such groups are called positive inductive effect groups. That means if the number of positive inductive effect groups or the electron donating groups increases around this carbon, the charge will further decrease, resulting in the carbocation to become more stable because it's moving close to having no charge. So if it is attached to 3 alkyl groups, all these 3 alkyl groups will be inducting its electron towards this positive charge, and this might have any, I'm just supposing these values, these are not actual values, 0.6 into 10 raised to power minus 19 coulomb, which is far much less charged than the methyl carbocation. That is why this is the most stable carbocation. So when there is a time that the pi bond breaks and one of them has to let go of their electron, and one of them, the left carbon and the right carbon, will have to carry a positive charge, then which one will carry the positive charge first? The one which will form a more stable carbocation, the one which is attached to more carbons, which is similar to the Markovnikov rule, because the one which is attached to more carbons is actually the one which is attached to less hydrogens. And if that carbon has to carry a positive charge, then the other one which is attached to more hydrogens has to bond with the electrophile. Now look over here. This one is attached to 2 hydrogens. This one is only attached to 1 hydrogen. That means this carbon is attached to 2 alkyl groups. One is methyl and one is this carbon. This is only attached to 1 carbon. So let's make it easy. More hydrogens means less alkyl groups. So this has more hydrogens, that means it has less alkyl groups. This will not form a stable carbocation relative to this one because it has less hydrogens, that means it has more alkyl groups. That is why this carbon, if this carbon has to carry a positive charge, this is your primary carbocation. Primary carbocation is less stable compared to this one. This one is secondary carbocation. Secondary carbocations are more stable. That is why this carbocation is formed in larger quantities and results in the major product. This one is formed in lesser quantity and results in a minor product. Let's take a look at this again in terms of stability of carbocation. So if you start a reaction with propene and there is hydrogen bromide, this is your electrophile. The electrophile will be attaching to the carbon with more hydrogens, so that the other carbon which has less hydrogens or more alkyl group gets the positive charge. So the electrophile should come to this carbon and not this one, so that this one carries a positive charge and forms a secondary carbocation which is more stable. But sometimes this doesn't happen because of probability of chance, possibility of chance. There is a chance that this bond might break under certain conditions, but that is not a favorable situation, because if the electrophile joins this carbon like this over here, the carbon with more hydrogens and less alkyl groups has to carry the positive charge, and such a carbocation is the primary carbocation which is less stable. So this is not a favorable situation. So such a carbocation is discouraged to be formed and is formed in less quantity. So that is a minor carbocation intermediate that results in a minor product. So if the examiner asks you that why 1 bromopropane is formed in less quantity compared to 2 bromopropane, your answer would be that the intermediate of 1 bromopropane is a primary carbocation which is less stable, compared to the intermediate of 2 bromopropane which is a secondary carbocation which is more stable. So that's your precise answer. I hope this topic was clear to you, and after this you are supposed to solve all the MCQs I have given you in the past papers related to alkenes. You have to give me your feedback that if the videos were clear, I have to do them again and have to improve on something. If anything was not clear on the board, I have also taken the pictures of the board and are sending those to your groups. And please go through these videos thoroughly and read the book. Also take help from the other YouTube teachers videos, and after solving the topical past papers, get back to me with your queries on your selective WhatsApp group. I'll be doing a live session on Zoom. The timings will be posted in your specific groups, so that you can one-on-one ask me anything you can need me to explain again from the video, or is there any question that is bothering you. Thank you very much.